All right, so with chapter 8, we're in 8.5. And it is conditional probability. And conditional probability, it's where basically they're going to tell you that you're going to find the probability of an event. And then the conditional probability part of it is that you're given some other event happening. Okay. And the one formula that they give to you for this one, for this part of it, is, oh, sorry, one here. When you're doing conditional probability, when they show it, it's going to be probability of E given F. And to work that out, that's the intersection of the two events happening. And then you're going to divide that by whatever it was, the probability of the event that you were given. So it's the probability of an event E that you're given. Another event's already happened, which they're going to call it F. And the only thing you have to remember is that if you're doing P of the intersection here for that part, and this is something that we did earlier, that's just where it's going to be the probability of E times the probability of F. And you also have the formula that we did from a little while back. Just need to hang on to that one also. The E union F. Which was the probability of E plus the probability of F minus the intersection. So all those are still there. Those same formulas from back early in the earlier parts of chapter 8, they're still saying hang on to those because you might need some of those as you go along through everything here. Okay, and pretty much that's the whole thing that they're having you look at for conditional probabilities. Basically, spin off those and just give you some different examples, show you some things of what it could be, and give you some options for what this thing is. So it could be it's the probability of getting a 6. If we're talking about spinning like on a number cube for this one, sorry, or on a die, the probability of getting a 6 given that it's even. Okay, so basically they're saying, all right, we're only getting even numbers off this thing. We're going to roll it. We're not going to get an odd. So in this case, you've got 3, you got 2, 4, and 6. So there's 3 numbers. So probability of getting a 6, given that it's even, well, that's just going to be 1 out of 3. Okay. And sometimes they'll even flip this thing around. What's the probability of getting an even? Given that the roll is a 4. And sometimes that's one that's you have to kind of. Sometimes you almost have to reread some of these questions because it's almost like it's backwards. But in this case, this is some of the problems that kind of set it up this way. The probability of getting it even, given that the roll is a 4. Well, if it's 4, it is even. So, it's already an even. So in that case, your probability would be a 1 because if it is a 4, it is even. So there's no other way you can get it something other than that. All right, and if you want to, this is where we'll go back and pulled up some different numbers, printed these out to make it go just a little bit easier instead of going through some of these. And this is some of the same questions you would see here. But if you need to, back on Blackboard, there's the handout that's got this sheet of some examples on it. Really got this mostly for the 2 examples at the bottom, but I went back and added these in as well to walk through. So if you have that sheet, if you want to go back and look at it, we'll go through these questions. Okay, and it's not focusing in really well. And then I get the focus, then it zooms way out. So, well, hopefully, again, I'll make the print a little bit bigger next time. But if you want to look at this one, if you want to pull this up, it's on Blackboard. It should be under your course content. It should be the notes there for that part. Okay, and the first 2 questions pretty similar to what we had here. It says a fair die is rolled. Number 1, find the probability of getting a 3, given that it's an even number. I'm going to take that out for now. Probability of getting a 3 that's even, well, that's the exact opposite of the problem we were looking at just a minute ago. If you're given that it's an even number, there's no way to get a 3. So for that one, that would be a 0. Okay, and then number 2, that's the exact same question we had a minute ago. I had written down. Didn't realize I put the same one twice. Find the probability of getting an even, given that the number rolled is a 4. Well, we just did that one. That would, of course, be a 1. Okay. All right. So number 3, here's where we're going back to cards. 2 cards are drawn without replacement. So we'll draw 1 card and then leave the card out, and we'll go back to a second card. So in this case, we're going to find the probability that the second card is a club, given that the first card is not a club. Okay, so again, for number 3, basically we start with 52 cards, and 13 of them are clubs, 13 are hearts, 13 diamonds, 13 spades when we go through those. So the first one is not a club, so we can throw that one out. So now we're down to 51 cards. So given that the first card is not a club, there's still 13 clubs that we're picking from. We're taking 1 card out and getting rid of it, so that's going to give us 51 cards now. So then it says now to the second one, what's the probability that the second card is a club? Well, there's 13 clubs. Once we've taken the first card out, now that there's no longer there 52, now we're down to 51. So for that one would be 13 out of 51. All right, and then number 4, still doing the 2 cards without replacement here. Finding the probability of getting an ace and a 7. Okay, and some of these you have to kind of read into what it's asking, because one like this is that when I first was thinking this one, that it doesn't give an order. So this is one where you have to kind of think about the order, that if you get an ace and a 7, it doesn't specifically say you have to get the ace first and then the 7 second. So this is one of those, you could get an ace and a 7. You also could reverse it around, so you could also get a 7 and the ace. As long as you've got them showing up, it doesn't matter which one's first. So you really have to almost look at this one twice. And I didn't leave enough room here for this one, so let me do this. So for number 4, we'll look at the first one for getting an ace first and a 7 second. So if we're getting an ace first, well, that's 4 out of the 52. And if we simplify that down, that would be 1 out of 13 for the ace. To get a 7, again, we're not doing a replacement on these, then we're down to 51, because we've taken the 1 ace out that we've drawn, so now we're down to 51 cards. There would be 4 7s you could get. So if we were going back to the conditional probability back here, if it's probability of the ace and the 7, we would just do probability of the ace times the 7. So that's going to be 1 out of 13 times 4 out of 51. And that comes out to be 4 out of 663. Okay, so that's if you do ace 7. Now, if you reverse it and do 7 and the ace, it's going to basically be the same thing, because there would be, if we did 7 and ace, if we got a 7 and then got the ace, the setup's going to be the same way, because there's going to be 4 out of 52 or 1 out of 13 that would be a 7. The aces would be the same thing. Now there's going to be 4 out of 51, so we'd multiply those two things together again. So that would be another 4 out of 663. So this would be the event of getting an ace 7. This would be the event of getting a 7 and an ace. So then we've got to add these two together. So then the final answer would be 8 out of 663. All right, and again, I think for me the hardest part on that one was realizing that it doesn't say you, because in my mind I got this answer first, and then I got the answer wrong. I looked at it and I was like, oh yeah, because in my mind I'm thinking, it has to be ace and 7, but it doesn't say it has to be in that specific order. As long as we've got an ace and a 7, doesn't matter where you get the ace first or the 7 first. So you got to look at doing both possibilities of getting an ace and a 7, and then getting a 7 and an ace. Now, if it said specifically that it was just ace 7 in a specific order, then it would just be the one set of numbers. But because we can get it either way, then we're going to look at 8 over 663. Okay, and number 5, we've got the probability of A is 1/5 and the probability of B is 1/6. And it says that A and B are independent events, so there's no overlap, there's no correlation between those two things. They're two totally separate things. So it's asking us to find the probability of A intersect B and A union B. Okay, so for number 5, well, if we do A intersect B, that's just the probability of A times the probability of B because they're independent. So that's 1/5 times 1/6, which would be 1 out of 30. Okay, and then for A union B, that's the same formula that we've been using pretty much the whole time here in chapter 8. That's where it's the probability of A plus the probability of B minus the probability of A intersect B. So that's 1/5 plus 1/6 minus 1 out of 30. And getting common denominators on all those would be 30. So rewriting this one would be 6 out of 30. This would be 5 out of 30. Of course, that'll stay the 1 out of 30. 6 plus 5 is 11, minus 1 is 10 out of 30. And putting it in simplest form, and then put you at 1/3. Okay, so if they're independent events, it's a little bit easier because they stand out from each other. There's no, one's given this, one's given that. It's a little bit easier, a little straightforward when it comes down to the problem when you set those two up for independent events. Okay, and they're really kind of building up because everything they're doing is conditional probability, and that's where we're going to look at the last two examples for what we have here. That for number 6, you've got a table here, and it's talking about color blindness. M represents the person as male, C is colorblind, so M prime is female, C prime is not colorblind. And it gives us this big table of everything that's here. So the very first thing, the one question I asked for in this case, is it says, what's the probability of M, the person is male, and that they're colorblind? So they told us up here that we're doing M given C prime. Okay, so what's the probability that they're male and they're not colorblind when we're going through these? Okay, so you've got P of M given C is a question that they're asking for that was back up here. So if you start looking at the numbers on this one, it's the intersection of M and C prime divided by C prime. So this is where you just have to go back through the chart and figure out what the numbers are here. So the intersection of M and C prime is just going back to the chart. Well, here's M, here's C prime. So that's going to be 0.543. And C prime is just the total then, because you need both of those. So that would be the 0.948. And then just divide those two things out. And depending on the problem, it's going to ask you to round it to 3 decimal places or 4 decimal places. You've got to kind of read through those because sometimes one problem, it bounces back and forth. Sometimes it's 3, sometimes it's 4. So for this one, we'll go to 3 decimal places. If you go ahead and do 0.543 divided by 0.948, that should come out to be, rounded to 3 decimal places, 0.573. Okay, and they should always give you whatever probability is that they're looking for. So again, it's just finding the chart, finding the intersection of those two things that you're asked to find, and then dividing it by the part that was the given part that's there. So they'd say, what's the probability of being a male given that they're not colorblind? Okay, and then the other chart, a little different version of it, but same type of problem, just a little bit different numbers when it comes down to it. This one was airlines, and we've got domestic and international. You've got the different types of airlines. They just went ABC here. And this was for 2012. It says find the probability that a flight operated by airline A is domestic. Okay, so for that one, we know we got to find the intersection of airline A and domestic. So that would be the 517,911, 517,911. And for the part that's here, find the probability that a flight operated by airline A is domestic. Okay, so they're asking for flights operated by airline A, so then we're going to divide that by the probability of A. So in that case, that would be the total that's here of 638,887. Okay, so again, you got the intersection of those two events, that's airline A and it's domestic, to get us the number that's here. And again, it's asking that what's the probability that a flight operated by airline A? So we got to look at the total of airline A that we got there. So then that would be that part. Divide those two. This one we're going to go to 4 decimal places. If you divide those two numbers, that should come out to be 0.8106. All right, and all the other problems that they look at is basically this, where you've got this chart, they're going to give you some probability that you have to find. And again, it's that same thing of just you're finding the intersection of those two events and then divided by whatever part it was that they were going to be given for those things. And they'll just keep repeating that same type of question over and over and over when it comes off of those. So it's just reading through the chart and just finding out those individual pieces there. And for chapter 8, for section 5, that's pretty much everything they can throw at you when it comes off of that. So, any questions for anything on 8.5?